Hello, everyone. Welcome to today's session of Web3 Classroom. Today, we're going to dive into the introductory session of EVM smart contracts or Ethereum virtual machine smart contracts. We'll explore what they are, how they work. I'm going to do some demonstration as well, and we'll go into how you can start creating, building, and deploying them on chain. So to start, let me just share my screen here. And hold on. All right. Okay. All right. So again, welcome everyone to this week's session. So as I've said, I'm gonna walk you through EVM smart contracts 101, or the fundamentals or introductory to smart contracts. Um, so we're gonna try to look into what is a smart contract is and what's the use case that can be built on using this digital contract or services. So first off, before we go into the details of what a smart contract is, what exactly is Ethereum, right? So EVM stands for Ethereum Virtual Machine, and basically the Ethereum, basically what if we need to know what Ethereum, what is Ethereum in the first place, right? So Ethereum, as you all know, is a decentralized and open source blockchain platform. So it's basically very similar to the Bitcoin protocol or any other blockchains. It's just that the Ethereum is sort of more targeted to not just tokens or coins, but also to any digital data that you want to put on chain. So Bitcoin, as you all know, it's good for transferring coins, tokens, right? Bitcoin, you can transfer it from one user to another, and that's it. There's like not a lot of use case to it. Ethereum, though, extended that functionality, the functionality of blockchain, to also make sure that it applies to applications, right? Use case applications, useful applications. So, and that means supporting any sort of digital data that you can persist on chain. So, like, aside from it having support to any sort of arbitrary data, it actually has an execution engine, right? So, and this is where the smart contracts comes in. So, the smart contract is basically a programmable or a service or a component that you can code, that you can build, and you can deploy in the Ethereum blockchain. And the EVM is the virtual machine or the runtime environment that executes the smart contracts, right? So smart contracts, they're self-executing. Put it on the Ethereum virtual machine, and then the Ethereum virtual machine execute that smart contract, right? And of course, when you do a transaction on chain, you have to pay in Ether, right? So this is what we call fees whenever we deploy or execute a blockchain transaction or a smart contract transaction. So again, like what's EVM, right? Ethereum Virtual Machine. So as I mentioned earlier, it's a runtime environment for smart contracts for Ethereum. So it's basically like a containerized sort of component that's living inside the Ethereum blockchain, and then it can execute smart contracts or digital contracts or code that you wrote in Solidity, and then run the logic that you sort of given it, right? So it ensures that the smart contracts execute in a secure and decentralized manner. And it's also Turing complete, so meaning it can execute any code given enough resources. So if the node that hosts the virtual machine has enough resources to execute a specific smart contracts, right? No matter how um, complex the logic is, it will do its best to execute, right? And persist all of these results and outputs on chain. So how EVM works? So EVM works when you write a code in Solidity, you compile it, and when you compile it, it turns that code into a bytecode, right? And that bytecode then stored on a virtual machine. You persist that on chain, and the virtual machine runs that code, right? So, before you even upload that bytecode, you need to specify the gas and the gas price and the gas limit. So basically, these are the fees that you need to pay to execute the smart contracts, right? So every transactions that you do on chain will cost you like a gas or a fee. And I think we all know this, that every time you transact, even with other protocols, right, Bitcoin and other data, even other protocols, there is a you have to like you have to you have to specify a gas price or a fee, right? Um, so okay, so now that we know that what Ethereum virtual machine is, and we know that we can code, we can create like a logic or a smart contract behind it. How do you actually create a smart contract, right? Um, sorry. Okay. Sorry. I was just hearing a lot of notifications on Discord. Yeah, so there might be some issues. Let me just triple check. Okay. All right. Sorry about that because I'm hearing a lot of notifications. So I don't know if there's something wrong with it. Okay. So just continuing here, the presentation. So how do we actually create a smart contract, right? So the Ethereum Foundation, the core devs created a programming language called Solidity, so that you can write a contract, and then and code your logic on chain, right? So Solidity is a high level programming language for writing smart contracts. It's statically typed, so contract oriented, and it's specifically designed and targeted to the Ethereum virtual machine. So this means that if you even get that bytecode, it will only work and it will be executed in an EVM compatible runtime environment, right? So and the syntax is very similar to JavaScript, right? So it's making it accessible for developers. So it's very similar to one of the most popular programming language out there, JavaScript, right? So any JavaScript programmers will easily sort of will easily know how it works and how to code it because the syntax is very similar. So advanced smart contract features. So in any programming language, there are state variables and functions that you can use. So you can actually have a state, variables that can store state on your contract, store state on the blockchain. So every time you change a specific state of a variable inside a smart contract, that will be persisted on chain. Functions. So if you are familiar with classes with object-oriented programming language, and in other, there is a concept of functions and methods. There are modifiers, so to use codes and add conditionals to the function. So you can you have still have the same operational operators, conditions, access modifiers on the code. There is an event mechanism, so meaning when you execute a smart contract or a function on a smart contract, you can ask the smart contract to emit some events so that any listeners of that smart contract can get some information regarding, like, with regards to the transaction that you called. So you can programmatically bake that onto the smart contract. And yeah, usage clients can listen to or for events to trigger actions. So this basically means that when you have some sort of logic and then you need to inform some of other systems, right? That a transaction happened, that's you can actually do that through smart contract, right? So that's basically supported for on the smart contracts. So a smart contract is basically like a service layer. When the service layer that you can code and that's deployed on the blockchain. So every transaction is basically a call to the smart contract, and all of the state change that you do on that contract will be persisted on chain. So if you can think, you can actually think of it as like a middleware service that you can deploy in that service on the sort of deploy on the blockchain, and that service is gonna be there. The functions are gonna be exposed, and any dApps or any applications on top of it can call any of the functions on that smart contract, right? So it's really just a code, a business logic code, right? But the main difference within an actual business logic code, Web2 business logic code, is that all of the state changes are persisted on chain, right, on the block. So when you deploy smart contracts, there are tools. So similar to any programming language that we all know, when you are building a smart contract, you code it. There are tools that you can use to write it, and also to deploy it. So we primarily use Remix IDE. So I'm going to show you all later on how to use Remix IDE and how to deploy a contract and also call some of these functions. MetaMask. So since every blockchain transaction requires a signature, right, from a wallet, right, because you need to deploy and execute a smart contract, you need to have a MetaMask wallet. Any wallet will do as long as it can provide you with a private key for signing. And then when you deploy a contract, you write the contract, you compile it, and then you deploy it on chain. So I'm going to show you all later how to to do these steps. So yeah, let's just go into the demonstration on how to code a smart contract. So I've sort of already prepared a smart contract here. So I'm using Remix IDE, and I have two examples. A simple storage contract. So it's a deepen example where a storage provider can register on chain, and someone who wants to store their data can pick a storage provider that's already registered on chain. And a real estate example. So it's one of the my favorite example, like real estate, where someone can list their property, someone can buy their property, and can buy their property with Ethereum and list it for sale, and you can also remove it from sale. So it's kind of like a real estate registry smart contract, right? So it's a simple storage contract. So if you look at the smart contract right now, so I'm using Remix. You write your code using this. You create a Solidity file here on the contracts, and the syntax is very similar. Is very sort of straightforward. First off, you have to specify your Solidity version here on top. So this is mandatory. It's now at 8.26, but there's a lot of versions out there that you can use from the big. So it really depends on the compatibility of the chain, but it will always be recommended to use the latest versions. And if you look at the structure of the code, it's an object, right? You create a class, but it's called a contract, and then you name that contract as a simple storage, and then you create the structures. So you can create structures or objects that will represent any business logic that you wanted to put on the smart contract, right? So for example, in this case, in a simple storage, we want to represent a storage provider, right? So in a storage provider means that they can report their capacity and the price per gigabyte, right, that they wanted to charge the customer. And then we have mapping here. So mapping is basically like a variable list that's exposed to the users. So whenever you add a list here, it's basically you can store data through it, address as the identifier, and you can call this mapping, this storage provider mapping, this provider's mapping to get the number of data that's already stored on this mapping itself. So this is actually one of the useful sort of features as well. So it's basically like a list that you expose to the outside world, right? To the outside the blockchain. And then of course you have your functions. So this is where you write your custom function if you want to register your provider. We write your functions here, and then of course we have two functions here. We have register provider and the store data, right? And if you notice, there is a payable here. So this basically means that this function here would need to have an Ethereum or a payment, right, along with the call of these functions. So this means that from a user's perspective, like when you're building a DApp, you call this function and then you also have to specify the number of Ethereum that you wanted to pass to call this function. So because the use case is store data, right? Because you want the user to store, and you want the user to pay to store that data. So you as a smart contract developer, you put a payable here, right? So that you can charge them with whatever with whatever pricing that you wanna specify here. So once your contract is done, so you just go here, and then Remix is very simple to use. You write it here, and then you go to the Solidity compiler. So first you compile it, right? So you have to convert it to bytecode. So you compile it, right? And the Remix will give you this checkbox here, if it's successful or not. If there's an error, it's gonna give you an error like this, a red with compiler error. So because I removed one of the semicolons there. So once it's compiled, you go to the deploy and run transaction. So when you deploy a transaction, you will see any environments here, right? So you can specify MetaMask as the injected provider. So basically, this is the signer. So this is where you will put where it will get the private key to deploy the transaction, right? So because deploying a transaction will require a private key, because you have to pay to deploy the smart contracts. So now we have this, and then we can also use Phantom Wallet, I guess like it detects the number of users here. Let me see if I can check my account. I need to check if I can just switch it over, right? Because I'm having some issues here. Okay, yeah. So this is testnet. So I'm using the Arbitrum chain on this example, but any EVM based chain will work as is, as long as it can connect to the wallet and can be detected here on the environment, right? So any EVM based chain, as long as it has the same backward compatible JSON RPC spec, it will work here. So here I chose 82C, the account that I'm going to use to deploy the contract. So I have significant amount of Ethereum here. Sorry, this is testnet, by the way. And then once that's all set, you hit deploy. When you hit the deploy, it will call MetaMask, and then you have to pay for that for sure. Of course, like every transaction on chain will have like an estimated fee. You have to pay for that for the deployment. Then you confirm that, and then you will see the logs here, the on underneath. Let me just put this here. You will also see the transaction hash here, right? And the contract address. So next step is so how do we test this, right? So two ways to test it. One is you use this, so that at the bottom of this screen here, or this deploy and run transaction, you can copy this and you can specify it here on this address, and then click on this. When you click on this, it will show you a list of functions that are already exposed. And now you can call these functions that's on chain, right? So you can also verify this on chain through transaction hash. So if I go to Arbitrum chain right now, you will see and paste that block hash, you will see the transaction here that I made 51 seconds ago, and this is the contract address that it created, right? So the contract is the same. It's D28, D28, and that this is it. And on the remix, you can specify that here on the address, and it will show you all of the publicly exposed functions. So now you can specify, you can register a provider first. Like for example, I'm gonna say 220 here, and the price is 1. So I'm gonna register it. Same, it's gonna call a blockchain transaction, confirm that, right? And then it's gonna create another hash here. So that means that the register provider has been registered on the smart contract, right? So how do we verify that? So we can verify that by creating an address here. So basically, it stores the address owner as the register provider address. So I think we can call this provider. So it exposes this as a public function. If you call that, you will see that this is registered, right? So I successfully registered a 20 capacity and 1 Ethereum price per gig, right? So now if someone wants to store a data, they just need to specify the price here, and then they will call this function store data, this one. So the second way to test this is actually running a JavaScript application or an application on top, right? So of course you don't want to test it here, right? You want to integrate it with your sorry, with a programming language that you're familiar with, either it's Go or JavaScript. So there is a library that you can use to do that. I've prepared a JavaScript file here on how that you can use to call that same contract, right? So this is an old contract address, so we're just gonna put the new contract address in here. So I'm just gonna put this here. And you need the ABI. Basically, this ABI is the the interface so that your code can detect the types, right? The types and the name of those types, and parse that and use reflection to parse those types and access the data that it has, right? So you need the ABI, and you can get this ABI through this as well, through the compiler here, the ABI code here. So there's a way to get. So the remix will give you all of the information that you need to create or to integrate with this smart contract. So in this example, I'm basically specifying my provider, I need a private key as well so that I can transact the contract address and the ABI as well. And then I have two functions that represents the function that I built on the smart contract, the register provider, sorry, and the store data. And I have this tool call here to register the provider and as well as store the data, right? So if I run that, I'm gonna get a transaction hash that's very similar to this. And if we look at that hash on chain, you're gonna see that it called this transaction here. Let me just get that the overview. It registered the provider contract, and if you go to the details, you just see the view output here. Maybe it's a default view. No, so you have to sort of get the hex version of this or decode this version to have a more readable state. But this is basically the register provider transaction hash, and this is the store data transaction hash, right? So you can the point basically is that you can build your Solidity smart contract using Remix, and you can write it here. You can compile, you can deploy, and you can either test it here, right? If you don't have any JavaScript code yet, or once you've done sort of testing it, you can start writing the JavaScript code to integrate, the smart contract onto your platform, onto your system. So Web3 JS is the sort of de facto library for for accessing Ethereum based chains. So this will work with any Ethereum virtual machine based chains as long as you know the RPC provider. So and yeah, so there are a few more sort of tools that you can use. So if you don't want to use testnet, the test network, you can also launch your own blockchain using Ganache here. There is a way for you to sort of create your own instance that's locally stored on chain. But to me, I would prefer to use a test network so that I don't have to store or to run a node, because that will consume additional compute capacity on my sorry, on my nodes, or also on my computer here. So one more example is the real estate. So very similar process flow. It's just that there's a lot more functions here. You can list your property. There's a buy property function. If you list for sale, so remove for sale. So the contract basically represents a business logic, right? So it's not a core, peer-to-peer, or not a core protocol sort of logic. It's really more for representing the real business logic that's for applications to utilize the blockchain, right? So every change that you do here on the smart contract will be persisted as a state change on the blockchain. So that means whenever you list a property, it will be stored on a property listed here. And then here, as you can see, there's an event. So this means that this function will emit an event to any listeners of these smart contracts, and sending them the message, or um, sorry, sending them the message of the property information, location, price, as well as who was the listing owner, right? So by property, there is a property sold, list for sale, for sale. Same process. You go to here, Solidity compiler, and then you deploy your transaction. So I've already deployed it earlier. I have the contract address. Um, I'm sorry, and I have the real estate sort of JavaScript file here to integrate that. So of course I can share this code to anyone who is interested to check them out. Yeah. But yeah, that's how you build your smart contracts. So it's basically how you sort of create a smart contract. All right, so let's just go back to my presentation then, slideshow. Right. So I sort of give an overview of how you build a smart contracts, or how you sort of can create a smart contract that that can be used for real business use case. And what I showcased was you can actually build a real estate sort of um, sorry, real estate registry where anyone can list and can also buy a house, right? So by doing so, we actually innovated, like we actually like created a more improved version of a real estate registry, where initially, right before, like now we're doing, there's like middleman, right? There's lawyers, brokers, and insurance between buyers and sellers. But now we have smart contracts that can facilitate the listing, can facilitate the buying, and can also facilitate the transfer of ownership, right? So once you have the state change on chain, the smart contract can dictate the ownership of that property. I'm sorry. So I want to emphasize the importance of like the whole sort of blockchain and smart contracts. The possibilities of building a smart contracts. It actually enables a sharing economy, right? So if you think about it, you can actually democratize different services using smart contracts, right? So if you want to share your compute resources, you can use a smart contract to sort of create a settlement layer between the compute provider and also the user, right? Similar with storage provider, right? So if someone has a spare capacity, they can actually share that or sell that to the user, right? And then through the blockchain and use the blockchain as a settlement layer via smart contract, right? So write the logic via smart contract, and everything is sort of decentralized, and everything is persistent on chain, and and every sort of state change is uh, is written on the blockchain. Right? So aside from the real estate and the storage, simple storage solution that I showed, there are real world applications that I'm sure everyone or most of you know how to use, or maybe have been utilizing for quite some time now. So decentralized finance, lending and borrowing platforms, Aave and Compound are using smart contracts heavily for their settlement. Non-fungible tokens, everyone here knows what NFTs are, digital assets that you can actually tokenize 100% on chain, right? So you can actually have a smart contract that can facilitate the distribution of these NFTs. The NFT itself is a smart contract, so it's an ERC 721 or 1155 specification. And then, of course, supply chain management, so transparency and traceability for products. You can actually build a smart contracts where a set of smart contracts that could represent each of the system or each of the step of a supply chain management, right? So that you can have, so if by doing so, you can have a traceability aspect of the supply chain, and you would know that specific items were delivered from point A to point B, right? So it's a great use case also for using smart contracts. So when you're building a smart contracts, of course, you have to have the security best practices there. Everything is immutable. So the main difference between building a smart contract and a typical Web2 component or service component is that smart contracts, when they're persisted on chain, they're immutable, right? So they're not, you won't be able to create, you won't be able to modify them. So once it's deployed, it's there. So all you do is just create a new version of that smart contract, right, on the chain. So that means you need to have a more bulletproof quality assurance and security process, right? So you need to have code review, you have to have test, you need to audit the smart contracts if there are any reentrancy or if there are any overflow, integer overflow or underflow vulnerabilities. You need to check if there are leaks, if there are hard coded private keys or hard coded keys on the smart contract itself. So there's a certain level of discipline, and as well as being thorough in terms of coding when you're building a smart contract, right? So smart contract was invented around 2013, 2014. It's not as mature as any other programming language. I know it's been like more than 10 years now. I'm assuming, yeah, it's more than 10 years now since its birth, but the use cases and the technology is evolving, and there's just a lot of use cases that's being built every day using smart contracts, right? So, and I think this is really a great opportunity for any developers, to look into this technology and see if they look in if it and and see if how they can sort of leverage it for their own needs, right? So there's a lot of resources available for learning smart contracts. So there's community and forums. So a lot of smart contract developers are using Reddit Stack Exchange, Ethereum Stack Exchange. There's even a Stack Exchange for specifically for Ethereum. There are courses available for for learning is Ethereum, Coursera, edX, Udemy, and of course the official Ethereum documentation is there. So let's go. Yeah, and yeah, that's about it. So I hope you guys are find that meaningful. We're gonna take some questions from the audience now. Let me unshare my screen first. All right. Oh, I have private chats here and comments. Hold on. Let me check. Let me check the comments first. There's no. I guess there's. Is there a tutorial applicable to real estate smart contract? Or this is actually this you can extend this to a real estate smart contract. Honestly, this example that I just built. Um, for a real so for a real use case, you would need to have more functions to add to those smart contracts because there are more business use cases, right? Business functions. But you can technically use this as a basis. Like you can use it and then just extend this to to whatever to however it fits with your customer or client. Um, yeah. So I was sorry. I was answering the question by Kaiser Val about is tutorial are applicable to real estate smart contract. Okay, so let's look at the private chat if there are any questions here. Yeah. So I think I answered this one. Is this tutorial are applicable to like smart contracts on public or just testnet? So they are applicable on both test and public. So you can use it. I'm gonna share it with everyone here later on. I'm gonna post it somewhere public, but you can technically use it and then extend it to whatever client or customer requirement that you have. All right. Right. So there's a question here. Hello, Alvin. I've been by Michael. I've been following you in Kristian for a while. May I know how you shifted from Web2 development to Web2 development? So I cannot speak for Kristian, of course, um, but I can speak for myself. But I shifted to Web3 because of the immense potential that it has in the digital space. Ever since I learned how to program, to code, I always sort of envisioned myself having an impact with my skill set, right? So I started as a programmer. I started as an enterprise application developer back then, right? But even before when I was still at college, I sort of envisioned myself that I would want to create something meaningful, or I would want to be part of something that's really impactful, right? So when I explored the blockchain tech, I saw the immense potential of it, just because of the privacy aspect, and also the immutability aspect of it. So I know that we are all moving to a digital domain, right? Everyone is storing their data on the digital space, and I know for a fact that we need to have a level of privacy and a level of security and immutability in place, so that and verifiability as well on the digital space for us to fully accept it. And I figured that okay, this is where I can make most of I can actually impact, right? I can actually create an impact. I create a positive impact, right? So that's like sort of like my personal goal. That's why I joined the Web3 movement. To this day, I'm still doing it. I've been in the three sort of cycles now, three cycles. But yeah, it's so that's basically like my personal reason for that. From a technical perspective, the solution works, right? So the democratization of services using this type of technology works. So when you're creating a shareable economy, or an economy where everyone can have an opportunity to share, right, or to sell different types of services, that's actually very good because it equalizes and gives everyone an opportunity to make better for themselves, right? And I believe blockchain enables that through its technology. Anyone can share NFTs, anyone can sell their assets, anyone can democratize their services, anyone can share their storage, their compute resources, they can sell their art, right? So it sort of creates this ripple of opportunities to everyone that are not available before the blockchain tech, right? So and that's the best way to make an impact, right? So contributing to that kind of technology. So yeah, that's what motivates me. Yes, 2017. Yep, Michael. Yeah. So yeah, 3 cycles. 2017, 2016. I started around 2016. Yeah. All right. Okay. All right. I'm not sure if there are any other questions on the. I'm gonna look at the private chat. Maybe Christian and Warves will sort of share some questions on other channels. How do I compute without any? I'm sorry, may tanong sa YT. How to get prices of tokens per 1 USD based on a total supply of token and total value? How do I do? Okay, so there's two questions here. How to get a price of tokens per one? So prices of tokens will be based on the speculative value, right? We all know this, right? If you're willing to pay for an asset, at this specific price, then that's going to be like the price of that specific asset. Very similar to how tokens work. So if the majority of the people thinks that this token is 1 USD or 1 or 2 USD or 3 USD, then the price of that token will be 3 USD, right? So whoever holds sort of like the majority of the token can technically like control the price of that specific asset. So getting the price of tokens per 1 USD based on total supply of token and total value of USD is really just like based on how the token economic work, right? So and it's very dynamic. It's such that it really depends on the use case of the token and also the number, the community, the user base, the usage itself, and the potential use case that of this specific token, right? So yeah, so it's a sort of like a mathematical computation that you need to run by to run on yourself. So it just and but if you're just simply asking the specific token value, then you can just go to any other sort of exchange. CoinGecko would be a good basis if you want to know the USD denomination of a specific token, right? If it has value, right? So how do I do the computation without any fractional loss? How do I do the computation without any fractional loss? I'm not sure how to sort of answer this. How do I do the computation without any fractional loss? ERC2 with different 20. I guess like it depends on how you're what's the I guess like I need more context on this. How do I do the computation without any fractional loss, right? So yeah, I need more context on this. So let me get back to the questions once I have more context. Is there a chain you could recommend we start with if we're a newbie? So I'm a EVM based chain, so I'm biased in a way. There will be some developers there that's gonna say that, oh, Solana is the best. Solana has really good DevX, really good tooling. But I believe EVM is sort of the de facto smart contract and virtual smart contract virtual machine platform. Most of the chains that are mature, most of the chains that are reliable runs on EVM. Even those that are, like for example, Cosmos or Substrate frameworks, they all have EVM compatibility layer, right? Because they sort of accepted that, okay, we need to have this EVM compatibility because we need a way for cross-chain transactions with any EVM-based chain. So I mean, I would say first is do Solidity smart contract. We learned that. My secondary would be the Solana, right? SVM. Sorry, yeah. Context, right? Creating a token on a launch pad. Wait, Hold on. How do I do the computation without any fractional loss? Without any fractional loss. In a launchpad. So, like, so are you building a token? Okay, creating a token on a launchpad. How do I do without any fractional loss? That's interesting. So you're basically building a token, or you're asking the launchpad to create you a token. Mm, I guess like if you want to have sort of a technical solution for to prevent any fractional loss, then you need to sort of monitor the price movements, right, of the token itself, right? And you need to trace. So each of the blockchain will have some sort of history or provenance on the specific token. So if you're creating a token, and if you sort of created a token on a specific launchpad, there are sort of bots out there that will sort of detect any sort of price movements, right? And then you can base your decision on what on if if you can base on decision based on those movements, right? So and you just have to like do the events or do the actions that will prevent you from any fractional losses of the specific tokens, right? So yeah, yeah, manual. So I guess like in any in my opinion, in any if there's any sort of conversation about preventing any fractional losses of like fractional losses, you always like sort of you have to sort of monitor the price movements, right? So you have to check what is the trend of the specific token or specific asset, right? And ensure that you have the controls and mechanisms to monitor the price movement so that you can make decisions before a loss can happen, right? Or at least minimize the losses that you have. So it's really like very dynamic, like in terms of how you're gonna do that. Tokens are varies from but one thing's for sure is that when Bitcoin goes up, most of the asset goes up. When Bitcoin goes down, most of them like most of them pulls back, right? But sometimes when Bitcoin goes down, most of the assets goes up. So it really varies, right? So yeah, so I'm not sure if I answered that question, but that's basically like my yeah my sort of thoughts onto it. What's your best advice for aspiring smart contract developers? Uh, so learn the technology, learn the tools. So I showed the tools that the Remix IDE earlier, how to deploy a smart contracts. It's actually very straightforward as long as you know MetaMask and Remix and how to create like how to use the proper libraries. Contribute to open source projects, commit code, apply. Like any other programming language, you have to learn the theory, but you also need to apply, right? You need to code. You need to actually code and apply those practices in either a small project or in a real world project, right? So look for opportunities where you can learn smart contracts. There's tons of opportunities right now in the Web3 space, especially for smart contract developers. So yeah, I mean that's my advice. Just learn it and then apply it. So don't just learn it, right? So theory is not gonna get you anywhere, honestly, in my experience. Uh, and applying it, right? Actually coding it, um, getting your hands dirty is the way to learn. Yeah. Yeah. So IT Renzo. So I think I think we can discuss this offline because there's just a lot of sort of things that we can like I don't know, we can come up with when it comes to this fractional losses. Honestly, actually have a lot of um yeah, I can discuss this with you at a later time. I think Yeah. I'm just looking at the questions here. What are your thoughts on Bera Baddies? I don't even know what that is. Bear Baddies. What is that? Is that an NFT collection? What is that? See how Chain advocates. Oh, interesting. Chain is a well-funded project. They're based here in Toronto. They contacted me a few times because they are Cosmos Chain, and I know how to sort of build a blockchain in Cosmos. Um, um, I don't know what Bear Baddies is, but they're if they are positively advocating Bear Chain, and that's good because I think Bear Chain is a good project. It's it's a the work that they're doing to sort of sorry to build a better settlement layer using Cosmos SDK is good. Sorry, yeah. What chains are you bullish on, and why is a smart why as a smart contract developer? What chains are you bullish on? Chains that I'm bullish on. Uh, I only have three kings: Bitcoin, Ethereum, and I guess like Solana. It's the third one. Uh, but those are the three I think to me the safest. Not advocating for them, but I'm just sharing that I think um, they have they are the key players in this space, right? Not just from a token value perspective, but also from a adoption perspective. Like institutional investors, retail investors are now looking into like these tokens, and it's good for the price movement, but it's also good for the entire ecosystem, right? For the entire space. That it's because we're getting more eyes on the technology itself. So those are the yeah. So I think that those coins I support because of the impact of adoption that they have on the space. And why as a smart contract developer? What chains are you bullish on, and why as a smart? I'm assuming you're asking why am I a smart contract developer. So technically, I'm smart contract development is just one of my sort of skills on the Web3. So I'm a back end developer by profession. So I integrate Web2 and Web3. So basically, that's my advocacy on the space. And a smart contract is sort of like the perfect middleware for doing that, right? So and yeah, that's why I think it's to me that's why I'm a smart contract developer. Because of that goal of mine to bridge Web2 and Web3. Yeah, that's my motivation. With so many L2s Ethereum have at the moment, do you think we will get L2 saturation? Uh, for I guess it really I guess it really depends on. I honestly don't think there's going to be like an L2 saturation. I think we need L2s because L2s are the ones that are. So imagine like you have Ethereum, right, and then you have like sort of a side chain or an L2 that does all of the for specific for a business use case, right? We need those L2 to run for a specific use case for a specific vertical, right? They have their own purpose as to why they exist in the first place. And I don't think there will be a point where we don't have any use cases to support a faster transaction, right? Because one of the things that L2 is solving is the settlement, right? The faster settlement, faster transactions, right? And that's basically the key for us, one of the key for this ecosystem to be fully adopted, right? Faster transactions, faster settlement, performance, and more, and secure, right? So I don't think there's going to be a saturation in the L2. I think and honestly, in my opinion, I think having more L2s is actually good for the ecosystem, for the entire space, because introducing L2 means that you have a user base that will actually use your L2, right? And there's more users, there's more transactions, there's more usage of the entire technology space. So I don't think that's gonna be there's gonna be a saturation of L2 in so yeah. So there's always gonna be like an advantage or a use case that it will specifically solve. Yeah. What was your favorite smart contract use case? Before it was real estate, now it's Deepin, decentralized physical infrastructure. So if you guys know, Deepin is basically like democratizing any physical infrastructure network that can connect to that specific network, right? Compute, storage, or yeah, I mean those are the two like sort of basic stuff, basic use case right now. So smart contracts. So you can actually use smart contracts to create like a shareable economy or an open market of compute resources. So if you look at Akash is one of the earliest decentralized compute marketplace. They actually built a marketplace so that anyone can participate as a compute node, and then anyone with who needs compute, right? So this is more prevalent with AI and machine learning. Who needs compute can just go to the marketplace and look for a node that's already onboarded onto the marketplace, right? So, so that's my take. So before it was real estate. So I'm not saying that it's not real estate anymore, but now it's deepened. It's decentralized compute and decentralized storage. It's like one of my favorites right now. So it's good. Sorry. Okay. 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 What's the difference between having just 10 good L2s versus 100 L2s? So does it really matter like how like many L2s or 100? Actually, I think 100 L2s is better in terms of adoption, in terms of acceptance, because that means that there are more environments that are running that are complementing the usage, right? So of the entire space, 10 good L2s means that you don't have a lot of users, you don't have a lot of usage, just you have 10 L2s that are just running in there, and you have like and you might have a limited use case, right? So again, like to me, I see L2s as sort of like not just an aggregator or a transaction or faster transaction, but it also represents a specific use case, right? A specific vertical, right? So the more L2s, the better to me. It means that there are more users, there are more usage, there are more use cases. So yeah. Right. So yeah, so I think we're running out of time now. So I think we can if you have any more questions, you can reach out to our team or to me. I'm available on FB or LinkedIn. You can just ping me there. But yeah, so thank you for joining today's session of Web2 Classroom. So I hope the introduction on EVM smart contracts is informative. I tried to be as engaging as possible. Some source code that I shared. There's some projects that I also like built just so that we can demo it. We covered the basics of EVM smart contracts, how they work, how to deploy them, how to start creating them, and yeah, I mean for those who are to looking at smart contracts or be aspiring smart contract developers, I encourage you to continue exploring, continue experimenting, contribute to the open source projects, put your code out there, publish it on GitHub, right? Because applying it actually deepens your understanding of how it actually works, right? So it's really different when you code it, when you actually write the code itself. So yeah, if you have any further questions or need additional resources, feel free to reach out to my team. So I'm here. I'm an advocate of the tech space. I'm here to help. If there are any questions that I can answer, of course, I will answer it as truthful as possible. And again, I'm an advocate of this space. I want everyone to sort of like, my goal is for everyone to know the value and the impact of this tech. And if I can help you in any way to to understand that, then that would be great. So yeah, once again, thank you for everyone who participated. Looking forward to seeing you in the future sessions. So yeah, keep learning and stay curious. Yeah, thanks.